Hey everyone, today we'll be focusing on calculus today, and today we'll be focusing on this problem, and without any further hesitation, let's get started. And now, let's go over our next problem. So our next problem states, in particular, that f of x is going to be equal to 2 over x squared minus 16, where we need to figure out exactly the domain, then the given range as well. And as we know, domain refers to all real values in the x-axis, and range revolves around all the values of the y-axis as well. I'm going to draw our following axis at the same time. Then we'll have 1, 2, 3, 1, 2, 3, 2, 3, 4, actually 4 over here, yeah. 2, 3, 4. And what we'll be doing, given the fact that we already have this at the denominator, we already have a key indication, given the fact that we would be dealing with a rational type function, that our graph is going to look something like this, one case to another. It's going down all the way, just from a figure standpoint. However, we need to figure out exactly how it will be shaped in particular. So, first thing we need to do in terms of figuring out the range is that we have to discern the fact that, one, the denominator cannot equal 0. And so therefore, that means that x squared minus 16 cannot equal 0. And we will have to discern the critical points where the function in itself would converge all the way to 0. So where does that take place? Well, we do so by solving it. X squared is equal to 16, because what we do is that we just add 16 on both sides of the equation, and whenever we square root it, we get x is equal to 4. But since we are already dealing with the square root, we will have a plus or minus 4. Therefore, our domain is going to be negative infinity all the way to negative 4, and since we are dealing with a rational type function as well, we're not going to have a hard stop. We're just going to have this continue, and then it will be in union with negative 4 to 4 all the way to union 4 to infinity as stated. This is our domain. So in context, it should look like this. It's just going to keep going on and on. That case to another. Then on the range, on the other hand, this one would be a lot more simple, one case to another. However, in the context for our range, we would have to know exactly, because one, looking at the x-axis, we already discerned that, so negative x, negative y, positive y. We notice how, in particular, that the range in of itself, is, given the fact that we are dealing with a rational function simultaneously, it would typically avoid 0, but it's also in unison at the same time. So our range would also be from, as we can see from observing the y-axis, negative infinity to 0, in union, because the graph is still continuing, in union with 0 to positive infinity. We notice how on the y-axis it's going up and down, and so that would be our following domain and our ranges as well for our following equation. There we go. Let me just put it over here. There we go. And so, yes, that is our function with our proper domain and our range as well. And now let's head over to another set of practice problems. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure to feel free to please like and subscribe. And if you have any other questions as well, please put them in the comment section. And as always, take care. Cheers. Bye-bye.